we are the glue that then allows you to monitor quality in a standard way across all those platforms, materials, and processes.
Welcome to Seeking Alpha's CEO interviews, informed conversations with the best and brightest CEOs in the publicly traded markets. Quality of leadership is a decisive factor in stock performance. Our show provides intimate and in-depth investing discussions with industry leaders across all sectors of the marketplace. We publish excerpts on social media platforms and the full conversations on seekingalpha.com or on our highly rated Seeking Alpha mobile app under CEO interviews.
Welcome to Seeking Alpha. I'm your host, Jesse Redmond. Today I'm joined by Mark Ruport, CEO of Sigma Labs. Mark, thanks for joining us.
Thanks for having me, Jesse.
So I'm excited to talk about the company, but I'm also interested to learn a little bit about you. Can you just give us an overview of your background and how you arrived at the space and how you got started with Sigma Labs?
Sure. I've been in the software industry longer than I like to talk about. So it's been about 30 years. I actually retired twice. I retired once in 2009 after selling a company to EMC. It was a security and compliance company that's now part of VMware. And then I retired again in 2017 after working for a private equity firm, again in the software field. Prior to that, I ran several public and private software companies, starting in the database management field, and then content management, and then finally security and compliance.
And what is it about software that seems to fascinate you?
Well, I came out of graduate school and I went to work for Computer Sciences Corporation. And that was the time when we were selling time sharing. And that was the ultimate solution sale. So you'd walk into a company and say, what are you doing? And you'd learn about their problems and you'd put together a solution for them because there weren't too many out-of-the-box applications. So it's really the solution selling, solving a problem, and really changing the way a company works through automation and technology that attracted me to software. And as far as Sigma is concerned, it was very much along the same lines. I was invited to come down to see the company by some board members that I knew from previous working relationship. And I found a group of talented, dedicated people that had a purpose and a passion for what they were doing. And software people seem to gravitate to software companies because of a passion or because of a purpose. And when they do that, it's really an exciting time and an exciting place to be part of.
And how would you describe Sigma culturally? I'm guessing if you wanted to work there, it must have not just been the monetary part because you've had some success in your past. It must have been that you like the people, you like the culture. Am I on the right track here?
100%. So culture is very important to me. I think culture trumps strategy and it trumps execution, because if you have the right culture, you're able to attract and retain the right people. And if you have the right people that both have the integrity and the experience to get the job done, they'll come up with the right strategy and the right execution. And what I saw down in Santa Fe, where the company's headquartered, is a group of dedicated people that came out of Los Alamos Labs that were trying to take technology, theoretical science, and turn it into a product that really would advance additive manufacturing. And additive manufacturing, as a subset of total manufacturing, has the potential to really change the world in many respects. And I know that's overused, but it's really people with purpose, with pride, and with integrity. And that's what attracted me to Sigma Labs.
And Santa Fe is an interesting area in that regard. I used to do a lot of things in the investment and hedge fund business. And there's a big, or not big, but there's a renowned group called the Prediction Company that came out of the Bell Labs there. And there's a big quantitative finance community there, I guess you would say, which was kind of unexpected for me. So I've been to Santa Fe a bunch of times to visit those folks. And I'm not surprised that Sigma Labs is there too, just because there are so many talented people.
There are. Matter of fact, between Los Alamos Labs and Intel, we probably 70% of our employees came from those two organizations. And when you look at the theoretical science coming out of Los Alamos, and then the practical application of that coming out of Intel, it was really a good combination of people.
And for people, Mark, that aren't familiar with the company, kind of big picture, how would you describe what Sigma Labs does?
Sure. We're a software development company, and we develop quality assurance software for additive manufacturing. And if people are not familiar with additive manufacturing, it's a new technology that allows you to build things layer by layer by layer that could not be built with traditional subtractive manufacturing methods. And so our software monitors the build process while a part is being built to ensure the quality. And why that's important, if you look at additive manufacturing, there are a lot of variables. You have the printer, the manufacturer, the number of lasers, the material, the power of the lasers, and the design of the part itself. And during that process, any one of those variables can go askew. And if it does, it could affect the quality of the part. And that becomes very important because these parts are used in airplanes and satellites and automobiles and human bodies because they produce designs that are lighter, stronger, and more durable than could be produced with traditional manufacturing. So quality becomes really important. And if you look at the acceleration of additive manufacturing, one of the things that's held it back is not just the economics, but the lack of consistency and quality of the final part.
And when we say additive manufacturing, is that synonymous with 3D printing, or is 3D printing a subset of additive manufacturing? Or how should we look at that?
It's virtually synonymous.
Okay.
However, you're seeing the definition of additive manufacturing actually extended now into design, simulation, durability analysis, post-processing. So the 3D printing process is just one component of additive manufacturing. But for most people, it's one.
And how would you describe the opportunity here, Mark, in terms of the total addressable market? Can you just give us maybe big picture on 3D printing? Because I think that's the term. We can talk additive manufacturing too, but I think 3D printing is the term that resonates with a lot of people. Can you talk about the TAM for that space? And then, if I understand correctly, you're more specifically involved in 3D printing of metals?
Yes. So,
okay, so let's start big picture and kind of drill down there if you can.
Sure. So 3D printing, even though it seems to be a new technology, came out of MIT about 30 years ago and started with plastics or polymer, and has moved since then into other materials such as metal, carbon, and ceramics and other types of materials. The hardest problem was in the metal side because of the use of the parts into the various components and the machinery that I mentioned earlier, into aerospace and space exploration and defense and energy type of applications. So 3D metal printing uses powder, and lasers come and hit the powder, and it can be a single laser, a dual laser, a quad laser. And now there are OEMs that are producing machines with 12 lasers. So the lasers hit the powder and they create a small layer of metal. Each layer is about 30 to 50 microns, about the size of a human hair. So if you're producing a part that's this big and every layer is the size of a human hair, you have a lot of layers that are being built on top of each other. Because of the variables in the printing process, you have the probability that something might happen during that process. And you want to be able to predict that or stop the process so that you then preserve and don't waste material or don't waste machine time. So additive manufacturing, 3D metal printing is layer by layer. That's why it's additive as opposed to subtractive. Subtractive, a traditional manufacturing, you take a piece of raw material and then mill it down to where it met your criteria. So additive and subtractive are exactly the opposite of each other. Originally, polymer or plastic was used more frequently, and that's really advanced much more quickly than metal. However, metal has a much more profound impact on the world given the applications that it's used for.
And how big is the metal printing market, and what are some examples of areas where it's commonly used?
Sure. So if you take the metal printing market and you take the high end or the industrial end, right now in 2022, they expect to ship around 2,500 high-end metal printers, 3D printers. Each one of these printers goes for about 750,000 to 1.3 million. So these are heavy industrial machines. One 3D metal manufacturer is coming out with a 12 laser machine that I think that will cost about $3 million. So our addressable market is that high-end market of industrial printers. On the polymer side, the market is much bigger on the low end, but smaller on the high end. So between the high-end polymer and the high-end metal, there'll probably be about 3,200 machines produced this year. In the market, there are probably 15,000 3D metal printers already in use today. And our business model is not only to ship our software through OEMs on new printers, but also to retrofit old printers.
And is there any effort by the printing companies to, for lack of a better term, create the software overlay themselves so that they don't need to bolt on an additional expense like this?
Yeah, now this is a really important part for people to understand. So every printer manufacturer has their own monitoring or quality assurance software. The problem is over time, manufacturers are going to have printers from different printer manufacturers. The analogy that I use when computers were first being adopted widespread by companies, companies would pick a vendor, let's say IBM, and they would get the software, the system admin software, the database, the security software from the hardware vendor. Over time, it became more difficult to standardize on one computer manufacturer. So the independent software industry was formed, right? And the independent software industry, based on standards, then developed systems that went across a heterogeneous set of computers, right? And what drove that was companies working together through standards across a heterogeneous set of computers. The same thing is happening with 3D metal printing and 3D polymer printing. All the manufacturers ship it with their own software. It's basically a closed system. But as an end user, you're going to have different printers for different applications. And as companies merge, all of a sudden you get a homogeneous environment turns into a heterogeneous environment. Now, what you don't want is a separate set of quality assurance software running on each one of those printing platforms. You want a third-party agnostic system that goes across hardware platforms, goes across materials such as metal and polymer, and goes across processes. So within 3D metal printing, you have processes like powder bed fusion or DED. And so within each material and each printer type, there are different processes. And so what happens is you get a set of different printers, different processes, different materials. And we are the glue that then allows you to monitor quality in a standard way across all those platforms, materials, and processes. Again, if you compare it to computing infrastructures, you know, it's the same thing that happened with the computing infrastructure of companies. They went from one vendor to multiple vendors to separate systems to standardized systems that cover the whole enterprise. Now, that's important also for companies like Airbus that have supply chains that make different components. They're able now to say that the part must adhere to this quality, and the quality has to be monitored by a third-party quality assurance system that meets the standards of the industry.
And I was surprised, Mark, that the company had been around as long as it has. You know, even going back to December 2nd of 2014, I believe it was as much as a $45 stock. A, do I have that correct? And what's gone on in the history that drove it up so much 7 years ago, but the company is still alive and doing well today, but maybe doesn't have the valuation it once had. Is that accurate?
That's accurate. So I've only been with the company for 2 years, so I don't have the whole history. But basically, um, the scientists came out of Los Alamos labs, as I'd mentioned earlier. I like to say they're a bunch of theoretical scientists that built a theoretical product. They went public through a reverse merger of a public shell as the hype of 3D metal printing hit its peak. And a lot of people looked at the potential of the technology in the industry and said this was a great play. And the company was a little early. Metal 3D printing didn't take off as fast as the industry had hoped, primarily because of the lack of consistency and quality and the lack of materials and different types of powder that were being used at that time. So the company survived building technology and doing grants. And then in 2019, began to productize a technology. And that's when I got involved. And so you mentioned earlier, what attracted you? Well, not only the people and the technology and the opportunity, but the fact that I knew how to solve the problem that they were facing, which is how to take this technology, productize it, and get it into the hands of the 3D printer manufacturers and have it OEM'd through the printer manufacturers, as opposed to us going in and trying to sell it separately to the end user. But I think, this gets to the core of additive manufacturing and 3D printing. Potential in technology is dangerous. It's just like potential in children. It's tough to live up to it sometimes. And this industry has taken longer to form than people had expected. And I believe that if again you compare that to the software industry, when the software industry began to collaborate relative to standards and standard data, so you can move data around from system to system and so forth, the industry began to take off. The same thing's happening with 3D metal printing. You had these printer manufacturers that wanted to control their destiny and everything that had to do with the printer itself. And today you see not a rush, but you see much more openness towards collaboration. And I like to talk about radical collaboration, which is doing something that's not just in the best interest of you and your company and your customer, but also the industry. And that's beginning to happen. You see software companies that are collaborating to do end-to-end solutions to improve the whole process. And when technology begins to focus on solving the problem of the end user, as opposed to doing a proof of concept to show how smart people are and for technology's sake, then all of a sudden the productivity of the whole industry increases. And that's what we're beginning to see. We're beginning to see the focus on solving a problem as opposed to the focus on creating cooler technology.
Do you ever worry that you're not early, but you may be missing something or you could be wrong? And the reason I say that is I've been involved in a couple of things where I was early, and I found in one case I was wrong, and there was being a little bit myopic perhaps, or I got a little bit married to what I was doing and lost some objectivity. I see you grinning, so I suspect you have some thoughts on this, but do you ever think about whether you're wrong early?
100%. And you're exactly right. You begin to believe everything that you've said in the past, and so you get tied to the past, right? Mm-hmm. And you begin to believe it. And so that was one of the questions that I had. Is this a group of people that have built a solution looking for a problem, right? And the second thing is that you learn that if you're in an industry all by yourself and you have no competitors, you're either really stupid or really smart, right? So, I think we were early. We know there is a real problem out there. If you ask any constituent, whether it be universities, research organizations, end users, they all say that the standard relative to quality and consistency has to be addressed. And we're now beginning to see competitors coming into the marketplace because in 3D metal printing, you're getting this transition from R&D into production. And as companies move into production, they have to reduce cycle time, and reducing cycle time goes all the way from design through final product through the improvement of that design, continuous improvement. And the way that the 3D metal printing company has ensured quality before was to lock down the process. As soon as you lock down the process, you take away the agility, and the whole thing kind of slows down. So to answer your question, yes, I worry about being myopic. No, I don't worry anymore that this isn't a real problem that has to be solved. And thirdly, we see competition coming in to try to solve that problem the same way we are, being a third-party agnostic solution.
So in a way, the competition is validating, well, positive and negative, I could see.
No, it's validating, and it's good for the company because it increases the overall awareness of the need for quality assurance.
So let's dig into the offerings a bit. You have the PrintRite 3D Lite, Pro, and Enterprise. Can you walk us through the three models, maybe talk a little bit about price points, use cases, and what's most popular?
Sure. So those are the three for metal.
Okay.
We have for polymer, we just have the PrintRite 3D Pro. So that's our standard product. It enables you to support 1 to 3 type of printers, depending on the number of lasers on the printer. The light version is an entry version for people who are just interested in doing one type of metric. And it might be for a lower end metal printer that's doing dental components, as opposed to a high end metal printer that's doing an engine for a rocket, right? The Enterprise is for a customer that has more than 10 printers and wants to network those printers into a single hub, as opposed to having a 1-to-1 or a 1-to-3 ratio between our technology and theirs. And to understand that a little bit better, PrintRite 3D is an integrated hardware and software platform. And it sits next to the printer and through cables, hooks up optics. And through those optics, we're able to look at the layer by layer manufacturing of that part. And so we're moving towards a software only solution, where our software will be able to be integrated with the computing infrastructure of the printer. And that will bring down our price point tremendously. And that's another catalyst for the 3D metal printing, is to bring down the price point of all the different components. So long story short, and nothing in this industry is a black and white answer. Our pricing today for a single laser machine is about $100,000. For a dual laser machine is about $150,000. And for a quad laser machine is about $190,000. That's a perpetual license. We're in the midst of moving to a subscription model, where the average cost will get down to about $3,000 or $4,000 per month per printer. Okay. And we're also in the process of moving from a hardware software integrated solution to a software only solution for OEMs. And that'll bring the price point down even further.
Yeah, I would imagine a lot of folks aren't thrilled with buying additional hardware if they don't need to. How much of the cost do you think you can shave off by not having the hardware anymore?
The hardware is about 35% of the total cost, so
Okay.
we'll take that down. And then when you get to an embedded non-optional model with the printer manufacturer, you're able to bring the software price down considerably.
And when I was reading about 3D metal printing, not necessarily specific to you guys, but just in terms of talking about trying to understand the bigger picture a bit myself, I've never used one of these. I've just seen videos of them. Can you talk a little bit about what the promise is of the 3D metal printing and also what's holding it back? And on the holding it back side, the word I kept seeing over and over again was consistency, lack of consistency. But that also seems like maybe a good thing, because it maybe is an opportunity where you guys can step in and add that consistency. Am I on the right track here? And just can you give us an idea of like what the promise is and what's holding it back?
Sure, you are on the right track. So the promise is to be able to manufacture components that could never be manufactured with traditional processes. So take a jet engine. GE has taken 350 parts of a jet engine and made it a single additive manufacturing part. So 300 parts down to a single part. Now think about that when it comes to maintenance and durability. The maintenance is much lower. The durability is much greater. The strength is greater. The weight is less. So when you're thinking about more durable, lighter, and designs that you could never do before, that's the promise of 3D metal printing. So right now it's low volume, high value type of parts that are being printed because of the economics. The second promise of 3D metal printing is to be able to print on demand close to where the part is needed. So if you take an oil and gas company and you have spare parts, you want to have factories around the world that are located. So if a rig goes down, you can manufacture a part, and that part can be back on that rig, and the rig can be up and running in a matter of hours or days. So it's the Amazon model of being able to put the distribution as close to the actual requirement where the part is needed as possible, so you can get the rig up and running. So customization, on demand, and high value, low volume parts are the promise of 3D metal printing. The thing that's held it back, as you rightly said, was consistency and quality. And the reason, again, consistency and quality are so important, or so, I guess the word are holding the industry back, is because of the number of variables. This is still a relatively young industry with a lot of innovation. There's new materials coming into the market every week. There are over 50 printer manufacturers on the metal side alone. And then you have all the different design criteria that people are trying to push the envelope. So they're trying to design things that have never been designed before, use materials that have never been used before, use a process that is by definition imperfect. And that becomes a cycle of innovation. And our job is to be a catalyst to accelerate the adoption by reducing the cycle time, by being able to produce more consistent and lower priced parts.
And is there a favorite customer example you can share with us in terms of clients that you work with? I noticed Lockheed was a client, and when you got that contract, the stock had a nice jump. Is that a good one to talk about, or is there another one you prefer?
Yeah, no, that's a good one to talk about. We're right now within Lockheed's research and development organization. So they're working with us to monitor temperature, monitor quality, do calibration across different machine types, because that's what they have to deal with their contracts and within their own manufacturing groups. So we'll see them go from R&D into production as they become more comfortable with the technology.
Okay. And how do you distribute the product? Is there a sales challenge here, and how are you addressing getting it out to the market more?
Yeah, that's interesting also, Jesse, because as we talked about earlier, you have the manufacturers with their own monitoring systems. And of course, they're selling their monitoring systems with their printers. So we had to begin by selling to the end users, such as Airbus and Lockheed and Mitsubishi and Baker Hughes, to be able to show the value of our technology to the end user, and also show that back to the printer manufacturer, right? So that was the first thing, direct sales to the end user. The second thing we did was then work with the printer manufacturers themselves and begin the OEM sales channel. So we have DMG Mori and Additive Industries who now ship our technology with their printers. The third thing that we're doing is certifying other printers as PrintRite 3D ready. So we take an EOS printer or an SLM printer, we then hook up and certify our technology to ensure that it works as we described and as is documented. So the primary channel is direct to the end user. The secondary channel is the OEM channel. You'll see that switch over time. So our plan is to have 70% of revenue come through the OEM channel, either directly with them selling our product or indirectly with them recommending our product and being certified to run with our product.
Is it weird at all for the printing manufacturer to recommend your product? Is that an admission that they don't have enough consistency themselves?
Yeah, no, this is a really important part because, and we saw a major change at Formnext, which in Germany in November, which is the industry's largest show. And so we went out and met with almost every hardware manufacturer, and we made the following case. We're not your competitor. We're not competing with your monitoring system. We have joint customers that have your printers as well as other manufacturers' printers. Our job is to help them to become more successful and more proficient in the manufacturing of parts. If we do that, you're going to sell more printers, right? So if we work in the best interest of our joint customer through standards, we're able then to do cooperation or be frenemies, right? And again, this is what the software industry learned, right? They learned that if they were frenemies and cooperation or competition, they were able then to lift the whole industry up. So it is kind of weird for them to admit and certify their printers as being PrintRite 3D ready. But when their customer has EOS and SLM and General Electric printers, the customer is the one that we have to focus on. And one of the things that's interesting is when technology begins to focus on solving a problem in the end user, as opposed to producing technology for technology's sake, or protecting their own ground there, that that's when you see the step function increase in productivity of the industry. And so it is weird, but the industry is so fragmented right now, and it's so difficult to make money. There has to be a way for companies to cooperate, to be able to sell more printers, to make them more efficient, and for the whole industry to rise. So I think you're beginning to see that transition.
Is there any chance that the printer manufacturers get their act together more, improve their software so it's more consistent, and therefore Sigma Labs isn't necessary?
That's possible, but it's highly improbable because there are so many different processes and different materials and different manufacturers today that they're going to focus on their core competency. So one of the areas we see the most interest is the new printer manufacturers that don't have access or the domain knowledge that we have and don't have access to resources that have the intellectual property that machine learning people, AI people, but people who specialize in metal cooling rates and things like that. They're going to focus on their core competency and where they can get the most differentiation. And it's not in showing the quality of their part. It's in the speed of the process itself.
Is there any chance you think that there's a big enough 3D printing company that might want to just flat out acquire you guys so that they have something proprietary there over the other 3D printing companies?
Yes. So, that's been a concern of mine because I think that will limit our evaluation. And I think that will also hurt the industry because I think the industry needs agnostic solutions that go across the different printers and processes. But we're a public company, so if somebody came after us, we only have so much that we can do. But generally speaking, that's not what we want. It's not what we're looking for. We're looking to grow this company because of the opportunity that we see in front of us.
And let's touch a little bit on your Q3 earnings call. I had a chance to listen to that yesterday, and it sounded like kind of a tale of maybe two things going on here. One is that you had really strong revenue growth. I believe that increased 182% year over year, but you missed on earnings by 12 cents. You lost 24 cents rather than losing 12, which sounds like that's what the street expected. Could you talk about what was going on that drove the strong revenue and maybe there was some spending perhaps that drove the earnings miss. Can you just touch on those two components for us?
Sure. So if you go back to 2019, and again, the numbers are relatively small. We increased revenue in 2020 by 100%, and our goal was increase revenue in 2021 by 100%. We had a record revenue quarter in the third quarter, both from direct and also from OEMs. I think the expectation was that we were going to have even a bigger quarter than we had. And so the expectations were somewhat out of line, number one. Number two, in the middle of the year, we decided that we needed to increase our spending relative to our OEM initiatives and our technology and the distribution of the new product, PrintRite 3D 7.0. So we consciously increased our expenses in Q3 and Q4 in order to get ready for 2022 and position us in the proper way. The other thing is that we raised money in the early part of the year. So we had a strong balance sheet and a long enough runway to make the push in the second half of 2021 in order to be able to dominate the market in 2022 through 2024. And our mission right now is to accelerate the adoption, but our job is to own the space of quality within additive manufacturing across printers, processes, and materials. And we see enough inflection point in the industry that we thought it was time to make the investment and make the push.
And where do you mentioned raising a bit of money. Where do you stand on the cash position these days, and what does the burn rate look like?
Yeah, the cash at the end of Q3, I think, was at 14 million. I'm not 100% sure, but it's somewhere around 14 million. We have enough cash to get us through at least this coming year, if not longer. So we have a good runway in front of us. The cash burn is going to be affected a little bit by our shift to subscription pricing from perpetual pricing. And we'll see how that affects the cash burn, because even with a subscription-based model, some customers will pay a year or two up front. We don't know the dynamics yet because we're just transitioning to the model. But the runway in the balance sheet is sufficient enough regardless to get us through the growth period that we're looking at right now.
So just to repeat back, because I think that's an interesting point that you said. So rather than taking in a big lump sum of several $100,000, now you'll be getting monthly payments for much of your business. Is that correct?
No, that's correct. So the
Okay.
subscription model will allow us to smooth our revenue out, and it also allows us to build a recurring revenue model in the future.
Okay. And in terms of the conversation today, I think you painted a pretty strong picture of the business as something you seem pretty comfortable with in terms of the outlook here. Is there something going on that keeps you up at night? Do you have any concerns? What do you worry about as CEO?
The biggest concern we have right now is what not to do. So strategy is not just what to do, it's also what you should not do. We have so many opportunities that we're being pulled in so many different ways, not only from partnerships and OEMs, but also from end users, different materials, different processes, that we have to be very careful that we don't stretch ourselves too thin. That's the biggest thing we worry about. The second thing I worry about is the culture of the company, is being able to retain the talent that we have. And the reason that's become more important with people working virtually, it used to be if you're in Santa Fe, you didn't have too many opportunities other than Los Alamos and the other organizations that we talked about earlier. And now we have people that are being recruited, by West Coast, East Coast, Austin, Texas, all over the world. And so the things that keep me up at night is focusing on the areas that will give us the greatest return, number one, and maintaining a culture that keeps people engaged, enthusiastic, and committed to the company.
Have you run into any unique challenges so far in this work from home environment? Do you still have a big office that people are coming into sometimes, or is it pretty decentralized at this point?
It's very decentralized, and we were fortunate for the most part that we were somewhat decentralized to begin with. And a lot of our customers were in Europe and Japan, so we're used to working virtually. But we have experienced within the manufacturing group some increases in COVID over time where the manufacturing team has to come in. And so we're trying to balance between, coming into the office and not productivity, because productivity doesn't seem to be affected, but innovation is more impacted by working virtually than productivity. Matter of fact, productivity at the beginning went up as people worked at home and got used to it. But the thing I worry about is innovation and culture being dissipated over time because of the lack of personal connectivity.
Do you think the innovation is partially driven by the collaboration that's a little bit more difficult virtually?
And no doubt about it. It's the old water cooler type of thing, where you would have never asked the question or run into the person or had the conversation if you hadn't, bumped into them, because you just don't have the same serendipitous type of interaction that you would have in the office virtually.
And my final question as we wrap things up here, Mark, is can you share what you're most excited about this year, what you're most excited about going into 22?
The most exciting thing is this transition from technology to solving a problem, because if the industry makes that transition, along with the push that we see for standards right now. So you see a push for standards and you see a push for focusing on the problem. If those two things come together, you're going to see additive manufacturing begin to really take off much more than it is already. It's already growing at a 25% compounded annual rate. So it's growing, but the potential is so much greater. And I see that transition happening right now before our eyes as companies begin to work together and focus on the end user problem. And that's what we're most excited about.
Well, this has been fantastic, Mark. Thanks for joining us on Seeking Alpha, and best of luck moving forward.
Thanks, Jesse. I appreciate the time and the questions.